paint.
See, I can't read when it's upside down.
Oh, good thing. The boom that is going to be deployed comes out of this big long door. And there is a door. There is a big long door that's mounted in here. It's held in place by a little cable that's in the end of this little threaded piece here. You see how it can move really easily. There's a cable in there. That cable goes through two cutters, two guillotine cutters, and at the right time in the flight, the two cutters cut the cable, and there's a spring in behind the door, and it pushes the door off, and the boom then is allowed to come out. So this thing is mounted up here in this little wedge, okay, and it's held in place with a cable going through here, so that in the flight this doesn't move around, okay? The cutter cuts the cable, the spring pushes this, and it just tips and flies away, okay? And you'll find this out in the tundra. There's a prize for the guy who finds this, okay? When you're out in your snowmobiles next winter, or your four-wheel buggies, and you find this, bring it back to me and I will give you a prize, all right? So it does this thing, and then sends the information back to Earth. Sending it through this is the antenna. There's a whole series of instrumentation inside there. That's the gun cutter.
This part doesn't get painted, right?
No, this part will be just exactly the way you see it. So if you guys are up at Churchill and get the opportunity to actually go into the range and see the motor and the build-up, you sweet talk a guy called Murray Abbott. Remember that name, Murray Abbott. You sweet talk him into letting you sign your name on this stuff. And then your name will go into space. So don't forget the guy's name, Murray Abbott. You tell him your Uncle Andy told you to sign the payload, okay? We'll go in next door. Next door is the electric part of the ocean here. This is the lower part. Pardon? Oh, that'll come off. It'll burn right off. This is some of the electronics packages, and the ballast is mounted on here as well, right on this deck here. This is the nose cone one, and then this is sitting over the top of this. Comes down and matches with that. Watch my fingers. That's sitting like that, and there's a band goes around about here called a manacle ring. It gets deployed, doesn't get deployed in this one, no? And then that Teflon nose tip is right up here. So that piece up here will get very, very hot. This gets fairly. So that's the outside of the rocket. That's what you'll see when you go on. You see that big long skin sitting on top, and this will be sitting on top, and this will be on the top. Just gonna keep back a little bit. Kind of spread around that way a bit. Yeah, go around that way. The two gentlemen here, the good-looking gentleman over there is Corey Mack. He is our primo. He's a young guy. Good looking too. Okay. This here is the payload. This is what's going in all those skins, and you can see that there's miles and miles of wires and electrical gizmos and little things that go whirl and bang when it's flying. Greg here is going to just go through very quickly the payload and give you some idea of what it is. Oh, sorry.
Sure. Yeah, I can show you here. Let me take we have a bag on the instrument, the ions and the electrons, and what's going to happen in flight after we get to about, I think it's 80 kilometers, we're going to let go of the strap that's holding this, and this arm will deploy down. And then what happens is, as the rocket gets moved through space, it's kind of like a boat going across a river, and this instrument acts like a net going through, and so you force the particles into faster or to more towards the center than the outer ones, and so we can tell what way these particles, which is kind of like a stream in space, is flowing. and that's what we use to try and determine all these different patterns for these particles up there. And this is the same instrument that's going to be flying off to Mars in July with the Japanese satellite. Do you have any questions?
Are all the electronics in this part of your experiment?
No, the actual experiment is just this guy here and this one here. The rest of these electronics that have to do with the payload delivering power and turning it on and off.
How long did it build these pieces of equipment?
Well, we've been working on this instrument for 5 years as part of the Mars mission. So there's been development over that. And the actual build-up has been, it takes about 6 months to build this up and put it together.
Our experiment's going to be below this one, so a little further down the payload.
Did you see it's right behind, it's right there.
Oh, there it is. Okay. Okay.
Yeah. Yeah, you guys come here. This is the one, this is our experiment. Come over here, ladies. Series of them there. 6 of them, and the last, the ones two are ours, the Moze ones. And you can see what the windows look like on this side. Now don't touch them, but they got a piece of tape over top of them. But that's where the light's going to be entering in, and we'll be sending the signal down to us, which we'll have to interpret. Okay? Wheel. There's a lot of empty space here, really, isn't there?
Yeah, that was an existing bay, and we thought we'd just use that rather than make a new one.
It wasn't a real requirement.
When did you get these from Roots?
About a week and a half ago.
Okay. This is
They-
Wally
Eluk.
Eluk, yeah.
I'm the payload manager for the
Yeah, we met
active
with
payload in Bristol, so I'm responsible for making sure that all of the pieces of the payload are built correctly to meet the requirement we have and put together and tested and taken.
Don't talk about the batteries and other than trickle charge them right up until launch. Maybe I'll set you up for launch.
And he's right.
Wouldn't want a dead battery.
He's absolutely right. That's what we'll do.
Now, how do you monitor all these experiments once they're all put together? Once we get all the whole things put together,
Well, all of the data is gathered up.
like it's sitting before launch.
Yes.
There's little wires coming out that get connected.
Absolutely. All of the data is gathered up in one place in the payload. If you look over here,
explode. It just burns very, very quickly. When it burns, what happens when two materials burn? You have a fuel, you have oxygen, they burn, and what happens? You have a gas. A gas is formed. Same type of thing happens in here. We form a gas inside the rocket motor. Well, what we've done with the rocket is we've given the gas only one place to go. Okay, this is where you get to be really silly. We can do a class science experiment. Grab a balloon, blow it up.
How big?
Blow it up as big as you want. And whoever sorry about that. Okay. Up your shelf. Come on, there's plenty of toys for people in the back too. Okay. What did we put inside the balloon?
Carbon
We
dioxide.
put in air. Doesn't really matter what it is. No, don't tie it. Just hold on to the end of it. Okay. What made the balloon gonna zing all over the place, right? But what really happened? The outside air pressure was able to push in on the balloon and force all that air out the back end. And when we pushed the air out the back end of the balloon, there was essentially thrust applied to the balloon that made it go forwards. Now my balloon went spinning all over the place because it didn't have any fins on it. But it's the same idea that it pushed experiment, let go of your balloon, see where it goes. There we go.
I put something inside and it came flying back at me.
It did? You want your balloon back? Oh, yeah, go ahead. I don't really. There are more. And the part itself is quite light. Now, these particular fins it's called an S19 guidance system that we use. And these particular fins actually are fixed in space or turn the way they're forward in and no weight at the aft end, and that keeps them nice and stable and pointing into the flow and at their lowest drag orientation. We're talking. Sorry, we don't actually make that component. Rocket is actually going to go compared to the surface of the Earth when you compare it to the size of the whole Earth. So we're going to go what sounds like a long way up, and it sounds like a long.
Did blast off in Churchill today, putting the rocket range there back in business. It launched after a one-day delay due to poor weather. Just after 7 o'clock this morning, the rocket shot into the northern sky, the first time since 1989. The sounding rocket, built by Winnipeg's Bristol Aerospace, was carrying a payload of scientific experiments. Aerospace took over the range in 1994. It promotes the facility as a northern launch location for global telecommunications satellites. Today's launch was designed to help attract new customers and investors.